Начать запись. Дубль 256. Погнали. Hello, dear ladies and gentlemen. My name is Olga Simonko and I am a student of Stage 2 of Front-End Development JavaScript course at Rolling Scope School. And today my presentation is about design patterns in general and one of them in particular. So let's get started. What is a design pattern? In software engineering, a design pattern is a general, repeatable solution to a commonly occurring problem. So the design pattern isn't a finished piece of code that you can just copy and paste into your program. It is a description or a template for how to solve a problem that can be used in many different situations. Effective software design helps resolve issues that may not become visible until later in the implementation. Reusing design patterns helps to prevent subtle issues that can cause major problems and improves code readability for other coders. In addition, patterns allow developers communicate using well-known, well-understood names for software interactions. And no less important, that it sounds really cool when you see, oh, I see, let's just use singleton here, like a real programmer. The most universal and high-level patterns are architectural patterns. And here we have creational patterns that provide object creation mechanisms that increase flexibility and reuse of existing code. We have structural patterns that explain how to assemble classes and objects into larger structures while keeping the flexibility of these structures. And we also have behavioral patterns, which take care of effective communication between our objects. And today, we're going to talk about, tada, the factory method, also known as a virtual constructor. The factory method is a creational design pattern that provides an interface for creating objects in a superclass, but allows subclasses to change the type of objects that are being created. Let's imagine that we are creating a logistics management application. I've chosen this example due to my absolutely useless high education as a passenger transport logistic manager. So the first version of your app can only handle the transportation by trucks. So the bulk of your code lives inside that truck class. After a while, your client comes to you and asks you to incorporate sea logistics into the app. His company grows, and of course, that's wonderful. But what about our code? At present, most of it is coupled to the truck class. Adding ships to the app would require making changes to entire code base. Moreover, if later you'll need to add some more another type of transportation to the app, you'll have to make all these changes again. As a result, you'll have a messy code and you'll have to forget about the dry principle, which says you never repeat yourself. And here the factory method comes to save us. This pattern suggests that you replace direct object construction calls using the new operator with calls to a special factory method. The objects are still created via the new operator, but it's being called from within the factory method. And the return objects are often called products. At first glance, I have no idea if you see my pointer. I hope you do. At first glance, this change may look pointless. We just move the constructor call from one part of the program to another. However, consider this. Now you can override the factory method in the subclass and change the class of the products being created by this method. For example, here, the factory method in the road logistics class returns truck objects, whereas the factory method in the sea logistics class returns ships. Returns ships. Both truck and ship classes should implement the transport interface, which declares a method deliver. Each class implements this method differently. So the truck delivers the cargo by land, and the ship delivers the cargo by the sea. But the code that uses the factory method, often called the client code, doesn't see a difference between the actual products returned by various subclasses. The client treats the products, all the products, as an abstract transport. The client knows that all transport objects are supposed to have their delivery method, but exactly how it works isn't important to the client. It's easier to understand looking at the structure of this factory method. So here we have a product. We have the product which declares the interface, which is common to all objects that can be produced by the creator and its subclasses. It's like transport interface in our previous example. We have concrete products, which are different implementation of the product interface, like truck and ship objects. We also have the creator class declares the factory method here that returns new product objects. It was like create transport. It's important that the return type of this method matches the product interface here. And we also have creators which override the base factory method, so it returns a different type of product. Here was, I think, sea logistics and road logistics. And also you can note that the factory method doesn't have to create new instances all the time. You can also return existing objects from the cache or from the object pool or another resource or some other source. The applicability of this method is very wide, and you can use factory method when you don't know beforehand the exact types and dependencies of the objects your code would work with. Because the factory method separates product construction code from the code that actually uses the product. Therefore, it's easier to extend the product construction code independently from the rest of the code. And you can also use the factory method when you have to save system resources by reusing existing objects instead of rebuilding them each time. You often experience this need when dealing with large resource-intensive objects such as database connections or file system or network resources. So we can think about how to be done, we can think about how can we implement the reuse of existing objects. First of all, you need to create some storage to keep track of all created objects. And when someone requests an object, the program should look for a free object inside the pool and return it to the client code. But if there are no free objects, the program should create a new one and, of course, add it to the pool. So the pros and cons of this method are, first of all, you avoid tight coupling between the creator and concrete products, like we've seen in our previous example about the logistic app. And we have single responsibility principle. You can move the product. You can move the product creation code into one place of the program, make it easier to support. And open and close principle, it means that you can introduce new types of products into the program without breaking the existing client code. But here is one big minus. Your code may become more complicated since you need to introduce a lot of new subclasses to implement this pattern. I think the best scenario is when you're introducing this pattern into an existing hierarchy of created classes. Then it would be easier. And that's it. Thanks a lot for watching. Thanks a lot for your patience. And see you later. Bye.